Welcome to a new lecture in which we will present the output technologies for virtual and augmented reality environments. By the end of this lecture, you will have gained a fundamental understanding of output technologies, insight into current solutions, an outlook of future perspectives. When discussing output technologies in virtual and augmented reality, we refer to the hardware and software that deliver sensory information to the user. Typically visual, auditory, and sometimes even haptic or touch-based feedback. These technologies create immersive experiences that bridge the gap between the virtual and the real world, allowing us to engage the virtual environments in ways that feel real. In virtual reality, the goal is to create a fully immersive digital environment. This means blocking the real world and replacing it with a computer-generated space. Augmented reality, on the other hand, overlays digital elements in the real world, enhancing the physical space around us with virtual objects or information. So let's look at the output technologies that make this possible, starting with visual output. Visual output is the most critical component of virtual and augmented experiences. The displays and optics used in headset or glasses are designed to transport users into virtual environments or enhance the real world with digital overlays. Head-mounted displays in virtual reality use high-resolution screens to provide stereoscopic images. These displays are built to trick the brain into perceiving depth, creating a 3D environment around the user. To maintain this illusion, these headsets must refresh at high frame rate, typically 90 Hz or higher, so that movement appears smooth and natural. For augmented reality, displays use transparent lenses and cameras that allow users to see the real world and digital elements. These augmented devices rely on projection systems that overlay digital information directly into the user's fields of view, blending the physical and virtual. The challenge with visual output is balancing high-quality resolution with minimizing latency, which is crucial for preventing motion sickness and ensuring a fluid experience. Innovations in eye-tracking technologies will also allow for even more dynamic visual rendering and user interaction in virtual spaces. Besides visual output, we have auditory output, which is often underestimated but is essential for a realistic experience. Spatial audio virtually replicates how we hear sound in real world. With 3D spatial audio, sound's direction, distance, and intensity change as the user moves their heads or position. Spatial audio also benefits augmented reality, especially in virtual meetings, training, or entertainment applications. For example, AR glasses with built-in speakers can reproduce sounds that appears to come from virtual objects in the environment. This immersive audio helps to blend digital elements with the real world, providing an intuitive and seamless user experience. This is essential for gaming and professional applications, like training simulations where realistic audio feedback enhances immersion. Moving beyond sight and sound, haptic feedback or touch-based output is an exciting development area for both virtual and augmented reality. Haptics allow users to feel virtual objects, creating a more immersive and interactive experience. In virtual reality, haptic gloves and controllers simulate physical sensation from the texture of the object to the force of impacts. For example, in a virtual training environment, a haptic glove might allow you to feel the weight and texture of manipulating tools, improving your learning experience. In augmented reality, haptic feedback is still in its early stage, but it holds significant potential. Imagine interaction with a digital object overlaid in the real world, such as turning a virtual knob or feeling the texture of a product before buying it online. These types of tactile feedback will make augmented reality much more interactive and valuable in real-world applications like retail, healthcare, and education. The future of opto technologies is moving toward creating multisensory experiences. Today, researchers are working on integrating more advanced forms of feedback, including temperature control and smell. These kinds of experiences, while still in development, represent the next frontier of immersive technology. In conclusion, output technologies are the backbone of virtual and augmented reality experiences, shaping how we see, hear, and feel the digital world. With rapid advancement in digital spatial audio and haptic feedback, the future of these technologies promises even more immersive and realistic interactions. Whether gaming, training, or collaborating, output technologies will continue to redefine the boundaries between the physical and the virtual world.